Okay, so let us continue our discussion on recursion. So before moving further, I just want to make one point that I missed in the previous session or the previous video. So we saw this both of this example, and we drew the recursion tree for them. So yeah, so here are the recursion tree for both of them. We saw this and this one. So the point that I wanted to make was like, as I said in the previous video, right, that we can trace the output by going from top to bottom and left to right in the recursion tree. So it's not just about the output tracing, but we can also see the way the recursion calls are being made by going from top to bottom and from left to right. So here in this case, for this example, this first example where function f of n is calling f of n minus 1. So way the recursive calls are being made can be traced using recursion tree by going from top to bottom and from left to right. So let us see how it can be done. So f of 4 will call f of 3, f of 3 will call f of 2, f of 2 will call f of 1, and f of 1 will call f of 0, and f of 0 will terminate since it's a base case. So it will terminate and the control will return to f of 1. So f of 1 will again terminate, control will return to f of 2, f of 2 will again terminate, control will return to f of 3, and again the f of 3 will terminate and control will return to f of 4. So the way the calls are made are like f of 4 is being called, then f of 3, then f of 2, then f of 1, and then f of 0. F of 0 terminates, f of 1 terminates, f of 2 terminates, and f of 3 terminates, and then f of 4 terminates. So yeah, so you can also trace how the recursion calls are being made by going through the recursion tree from top to bottom and from left to right. Similarly for this example, so here f of 3 is being called. So here if we try to trace the recursion tree from left to right and from top to bottom, we will see that first f of 3 is being called, then f of 2 is being called, then f of 1 is being called, and f of 0 is being called. F of 0 terminates, control comes back to f of 1, again f of 0 is being called from f of 1, and f of 0 terminates and control comes back to f of 1. F of 1 terminates, control comes back to f of 2, f of 2 again calls f of 1, f of 1 calls f of 0, and so on. So if you go from top to bottom and from left to right, here you can see the way the recursion calls are being made here in this case. So this is true for any recursion tree. If you go from left to right and from top to bottom, you will be able to see the way the recursion calls are being made. Okay, so this was the point that I wanted to make. So let us begin with our today's discussion. So yeah, so for today we'll look into how to solve recursion problem. So basically there are 5 steps that I use for solving any recursion problem, which I have listed down here. So yeah, so the step number 1 is to identify that it's a recursion problem. So how do we identify whether it's a recursion problem or not? So for that we see if we can break this problem into smaller subproblems or not. And if we can break this problem into smaller subproblems, then yes, we can solve this problem using recursion. So yeah, that's the first step. Second step is once we have broken this problem into smaller subproblems, that is, we are able to break a bigger problem into smaller subproblems, then we'll draw the recursion tree for it. So in the previous video we saw how to draw the recursion tree from the code. So this was one of the example that we saw, right? But here while solving a recursion problem, we aren't given a code, right? We have to write a code. So what we do is we first of all figure out how can we break the bigger problem into smaller subproblems using step 1, and based on what our observation is in this step 1, we'll draw the recursion tree based on it. So we'll see how to do that. So that is the step 2, drawing the recursion tree based on the way we broke the bigger problem into smaller subproblem. Then the third step is to identify and write the template function. So we'll write the function template, which is the third step. The fourth step is to write the recursive calls, and the fifth step is to write the base case. So we saw what is recursive calls and what are the base cases in the previous video. So we'll see the practical example for it in today's video. Okay, so now let us see how can we apply these 5 steps that I discussed here to solve a simple recursion problem. So let us start with this example of computing floor of log base 2 of n, assuming that value of n is greater than or equals to 1. So let us see few input output cases to understand this problem better. So for the input value of 1, log base to 1 is 0 and floor of 0 is 0, so output should be 0. For input value of 8, log base to 8 is 3 and floor of 3 is 3, so output should be 3. For input value of 7, log base to 7 is 2 point something and floor of 2 point something is 2, so output should be 2. So now let us start applying the 5 steps that I discussed. So let us apply the first step to solve this problem. So first step is to identify whether it's a recursion problem or not. So to identify that, what we do is we look into whether we can break this problem into smaller subproblems or not. So here in this case our problem is to compute log base to n. So to check whether it can be broken into smaller subproblems or not, what we'll do is we'll pick up an example. So we'll pick this example which is computing log base to 8. Now can log base to computing the value of log base to 8 be broken into smaller subproblems? Yes, we can break it. So how can we do is the computation of log base to 8 can be broken as 1 plus log base to 4, and you can check that value of log base to 8 is 3 and value of 1 plus log base to 4 is again 3. So yeah, we have broken the computation of log base to 8 into computation of log base to 4. So we have in some ways broken the larger computation into smaller computation. So to further check if this pattern of breaking is correct or not, we can work out few more examples. So I've written one more example here. So to compute log base to 6, first of all the value of log base to 6 is 2.58. Now can we break the computation of log base to 6 into smaller subproblem? Yeah, again yes, using this pattern. So log base to 6 can be broken as 1 plus the computation of log base to 3, and if you see the value of log base to 3 is 1.58 and 1 plus 1.58, which is 1 plus log base to 3, is 2.58, which is the value of log base to 6. So in general the computation of log base to n can be broken into 1 plus computation of log base to n by 2, and yeah, so this is the this is how we can break the larger problem into smaller subproblem by identifying some pattern. So yeah, so now since we have identified this pattern, now let us draw the recursion tree using this pattern. So I have already drawn the recursion tree here. So for the two cases, for value of n being 8 and value of n being 7, so you can see here f of 8, or yeah, the function of f of 8 can be broken into computation of 1 plus f of 4, and again f of 4 can be broken into computation of 1 plus f of 2, and f of 2 can be broken into computation of 1 plus f of 1, and we know that the value of log base to 1 is 0. So f of 1 should return 0, and that should be our base case. So it will return 0. So f of 1 will terminate, and it will return 1 plus f of 1, which is 0, to f of 2. 1 plus f of 1, which is 0, plus 1, which is 1, to f of 2. Now f of 2, the value of f of 2 is 1. Now this function f of 2 will terminate, and it will return 1 plus 1, which is the value of f of 2, which is 1 plus 1, which is 2, to f of 4. So now the value of f of 4 is 2. Now what f of 4 will return is 1 plus 2, which is 3, and this value which is returned to f of 8, which is 3, will be passed to the main method, and that will be the final output. So this is the recursion tree for the f of 8 or log base to 8. So you can see that we have broken the computation of f of 8 into smaller subproblems, which is computation f of 4, and then computation f of 4 again into smaller subproblems, which is f of 2, and so on. So now let us work out for another case, which is 7, where the value of n is 7. So f of 7 can be broken down into computation of 1 plus f of 3, as we saw earlier, which is 7 by 2. So so this 3 is coming from 7 by 2. So f of 7 is broken into 1 plus f of 3. F of 3 is broken down into 1 plus f of 1, and f of 1 is 0, as we saw, since it's a base case. So this function, this call f of 1 will terminate and it will return 0, and so the value of f of 3 will be 1 plus 0, which is 1. So value of f of 3 is 1. Now the value that f of 7 will get is 1, value of f of 3 plus 1, which is 1 plus 1, which is 2, and f of 7 will return the value of 2 to its caller, and that is what is exactly the floor of log base 2 of 7, which is 2. We saw here, right? Here for input 7 we should get output value of 2, and for the input value of 8 we should get output value of 3. So yeah, so these are the recursion tree for both the cases, for this value of input and this value of input. You can even try for other set of inputs, let's say 16, 17, 20, 25, any value, and you will get the correct output for this you will get the correct computation value for floor of log base 2 of n. Now since we have drawn the recursion tree, and since we have also understood how the recursion tree, how the recursion calls are being made, now let us write the template function, which is the step 3. So here in this case, name of our function will be log base 2. It will take integer n as the argument, which is the value n here, and it will return the integer, which is floor of log base 2 of n. Now since we have written the functional template, now let us write the recursive calls inside the this function. So recursive calls will be simple. We have already identified it here, right? So recursive calls will be log base 2 of n by 2, and will do 1 plus log base 2 of n by 2, and will return that value. Yeah, I hope this is clear. It's it is just coming from here. Yeah, so that's the fourth step, and the fifth step is writing the base case. So as we saw while drawing the recursion tree, right, that the base case is when we reach f of 1. So when we reach the when the value of n becomes 1, what we do is we just simply return 0. So that is what is being done here. When value of n reaches 1, we simply return 0. So yeah, this is the final function for computing this floor of log base 2 of n.